So you got this data that you have to graph. And you're going to have to decide how to put numbers on this graph, on the time axis here and the position axis here. Now, usually you'd have a computer do this for you, but your teacher just gave you a piece of paper, and so you can't use your computer. So how are you going to do it? I'm going to show you how to correctly number the graph, and also a couple mistakes that a lot of people make. All right, so we have these numbers, and you might be thinking, hey, why don't I just count numbers by 1, 0, 1, 2, 3, and so forth. You can do that, but when we put the data on the graph, look what happens. Only 4 of the data points, the ones in black here, fit. The other ones are off the graph somewhere where we can't see them. All right, this is not good because this only allows us to see part of our data. So we can't do that. What if we just take these numbers and put them on the time axis and put these numbers on the position axis, just like they appear in the data? Wouldn't that be easy? So we do that, but that's no good, right? Because you notice that these numbers don't go up by the same amount. Here, you're like counting by threes, then you get to 18, it jumps all the way to 30. You jump by 12, and then 6, and then 12. All right, so you have to count by the same number. If you don't, then your data is going to show a completely different pattern than what you have in real life, right? It's going to cause you to think things are there that aren't really there. So you have to count by the same number. Okay, but you get to choose what that number is. So we can't do it that way. So how do we do it? Well, we get to choose which number to count by on the time axis. And we want to count by a number so that 16 will fit. Right? But we don't want 16 to be like way down here. We want it to be near the end. So we could count by twos. And that would put 20 here because we have 10 lines, 10 boxes in this grid. And so if we go by twos, this will get to 20. And that'll be good because our biggest time is 16, so it'll fit on the graph. And it'll fit near the end, which is what we want. All right, what about the position numbers? If we count by 2, then it only gets up to 20, right? Because we have 10 grid lines, 10 times 2 is 20. And that means that some of this data won't make it to the graph. It'll be up here somewhere. So that's not good. We count by threes, right? 10 times 3 is 30, so 30 would be up there. But still we'd be missing the last 2 because they're bigger than 30. All right, so if you're smart, which all of you are, you're probably saying count by 5s. Right? If you count by 5s, then the top one here is going to be 50. And the 48, which is our largest number, is going to fit on the graph, and it's going to be near the top, which is what we want. So we'll number like by 5s. All right, so notice this axis is going up by 2s. This axis is going up by 5s. Right? That's a well-numbered graph. And when we actually put the data on the graph, you can see the dots take up most of the graph, but none of them are going off the graph. So that's a well-numbered graph right there. So the secret is you got to kind of look at your highest numbers, look how many graph lines you have, and then multiply some number by the graph lines to see what your biggest number is going to be. And you want the biggest number to be just a little bit bigger, equal or a little bit bigger to your biggest time. Same thing with position. You want your biggest position to be equal or a little bigger than the biggest position you have. All right, now what if you have this kind of the opposite problem? You have data that's really small. Right? The biggest number we have for position is 1.5. So if we just number these by 1, which is like the smallest counting number that I can think of, then all the data fits. But look, it's only taken up this little piece of graph. And when you have this, you don't get to see all the details because it's like zooming out on a picture. So is there a way to do this better? Well, when we have small numbers, we can't count by something bigger than 1 because that makes it smaller. Instead, what we can do is we can skip lines. Right? So 1, between 0 and 1, there's 2 lines. Between 1 and 2, there's 2 lines. So basically, we're counting by halves. Right? But you don't have to write the halves. And if you do that, then it's a little bit better. You notice at least sideways it goes all the way to the end. Right? But we don't need this top part of the graph. All right, so let's do the same thing on the vertical axis. Okay, so that made it a little bit better, but still we have more than half the graph is blank, and so that's wasted. So we could go by 3s. That's a little bit better. Let's say go by 5s. All right, so there's like 5 lines in between 0 and 1, 5 lines between 1 and 2. And as long as you do it consistently, like the same number of lines between the numbers, then you're not going to lose the pattern, so it's all good. All right, so this is a well-made graph right here, a good example of how to number the graph if you're dealing with smaller numbers. All right, hopefully this helps. Have fun numbering your graph. I'll see you in another video.